Hi, my name is Man Chun. You can call me Jay. This video is a demonstration of some of the useful analytical tools produced in my final year project, analysis of international trade data correlating Chinese economic influence with Chinese United Front influence in Oceania. This video is not a replacement for the analysis in my thesis. It only aims to help you use the tools provided in the code for this project. I encourage you, the viewer, to read the thesis before watching this video. Let's start with the graph of world trade. The graph of world trade built consists nodes representing countries and directed edges representing the export of commodity goods. Each edge has a total export value and export values for individual trade goods. The value is measured in US dollars. Here we see that the graph is built using this function build_graph. A year parameter is passed in. There is data available for 3 parameters so far, which is the year of 1999, 2009, and 2019. Here we see that CAT centralities are computed for 2009 and 2019, and trade thresholds of 0, 0.01, and 0.02 are used. The trade threshold variable allows you to discount edges with small trade volumes. For instance, a threshold of 0.01 means that all edges that carry export value less than 1% of the exporter's total export value is not included in the graph. Effectively, this thins out the graph. This removes some of the lighter edges, the edges that have lower trade value. The threshold applies to both the total trade value and also the individual trade goods. And in the table here, we see the top 10 countries for different years, 2009 and 2019, and for different trade thresholds. Further down, we see a analysis for degree centrality. The difference between degree centrality and CAT centrality is that in the degree centrality, the exporter influence is not considered. So the export value of the exporter is not considered. Every node is treated equally, whereas in CAT centrality, nodes that are more influential are more central, and nodes that are close to more influential nodes are considered more central than the average. Here, network edge density is also considered. Network edge density is just the number of edges divided by the total possible number of edges between all the nodes. And network edge density only concerns total trade volume rather than individual trade goods. The clustering of nodes is also considered. Clustering is effectively if node A and node B are both receiving imports or exports from node C, what is the probability that node A and node B trade amongst themselves? So in this case, we see that when node A and B both receive exports from node C, there's a 0.75 chance of node A and B trading with each other, and the second value is for imports from node C. Now let's move on to the graph built for trade data in Oceania instead of the entire world. So because of usage limits, the trade data collected for world trade is somewhat limited to 3 particular years, 2009, 1999, and 2019. The data for each year is available for the trade graph of Oceania. So here, we build the graph in the same way as before, except there's no year variable being passed in because every year between 1990 and 2019 are considered. The first thing to show off here is the list of dependent trade goods. So this function allows us to look at select trade goods that are highly dependent. So, for example, here in the first parameter, we pass in the graph that we want to analyze. We pass in the ID of the particular node that we want to look at. So in this case, 36 is Australia. So we're looking at the export dependence of Australia on different countries. Threshold here, as discussed before, is the minimum limit at which edges are considered. Any edges with less than 0.8 trade threshold are discarded. And finally, the minimum number of years indicates how many years must a trade good remain above the 0.8 threshold for it to be displayed. Here we see that there is one trade good, one export good from Australia that is dependent on China, but because it doesn't reach the 5-year limit. It is not dependent for more than 5 years or equal to 5 years. It is not displayed. And here we see that there are 5 trade goods from Australia that are dependent on New Zealand, and out of which 2 trade goods, which is straw and carpets and other textile coverings, that are dependent for more than 5 years. We're also able to graph the number of dependent goods by year. Again, we put in the country in question and we put in the trade threshold in question. So in the case of Australia, we see that there are a lot of Australian trade goods that are very much dependent on New Zealand. When we change the country or when we change the threshold, you will see that a different list of trade goods are displayed. So if we lower the trade threshold, naturally there will be more dependencies. We see that there are a lot of trade goods from Australia that are dependent on China with higher than 0.4 threshold. And the threshold is fairly significant even at lower numbers, because this means that for all of the trade goods displayed here, more than 0.4 out of 1, so more than 40% of the trade value exported from Australia goes to China. And we see that there are 21 trade goods that are dependent on China. This graph displays the sum of all export dependencies between 2 countries, in this case of New Zealand exports to China. Each colored layer is a different trade good. On the horizontal axis is year, as the trade from 1990 to 2019, and on the vertical axis are dependence units. The dependence units are the same as trade thresholds previously discussed. 0.5 units means a 50% trade dependence, and a 1 unit means 100% dependence, and so on. The grid lines serve to indicate 1 unit, so you can compare the height of each layer to the nearest grid lines to have a rough estimate of how much that export good is dependent on China. For instance, the red trade good in the center is almost totally dependent on China in the early 2000s and quickly diminishes in the later years. The purpose of this graph is to show a more granular view of trade dependence between 2 countries on the level of individual trade goods, and this view is not possible by simply looking at total trade value dependence. Notably, when a particular trade good, even a small one, is heavily dependent on one importer, that importer gains political leverage over the exporter, and this is discussed in the thesis. There are many trade goods aggregated in the single graph, so the more important, or rather the more dependent trade goods are highlighted up here. These numbers are the trade good IDs that you can use a particular tool to translate. The tool can be found in Country ID Dictionary, which contains a dictionary that converts country IDs as well as trade good IDs. Some of these files may be renamed further on. The second graph here shows the proportion of trade good values. So the previous graph showed the trade good dependencies, a summation of the trade good dependencies. Note that the trade good dependence is a ratio, and this is the actual trade value, the proportion of the trade value. So this graph serves to ask the question: out of the exports from one country to the other, what proportion of that trade value comes from a particular trade good? So on the horizontal axis, again, are the years, 1990 to 2019, and on the vertical axis are the different trade goods, and each color represents one particular trade good. Again, the trade goods with particularly large influence, or rather with particularly large, that consist of a particularly large part of the exports, are displayed here. The trade good IDs are displayed here. Both of the graphs are customizable. So in this case, we passed in 3 parameters: the graph in question, the exporter, and the importer IDs. The exporter in this case, 554, is New Zealand, and the importer is China, 156. Here, ranking lists are computed for export goods. In this case, the exports are from 554, which is New Zealand, to China. the export goods are ranked by the export value every single year. And between every 2-year interval, we compare the first year and the second year, and we compute that Kendall-Tau distance, and we graph that Kendall-Tau distance. So effectively what this graph shows is the volatility in the trade good rankings. So we see that in the earlier years, the trade goods change in significance quite a lot, and as we approach modern day, the trade goods sort of stabilize into a particular hierarchy where some trade goods have larger export values than others. Further on, we have some visualizations of trade dependence on China. So in this case, we see Australia and New Zealand's total trade dependence. So we see that in the earlier years, there's fairly small trade dependence, and then somewhere around 2004, the trade dependence suddenly grows at a very high rate. Similar graphs can be obtained between Australia and New Zealand and a set of countries. So in this case, the set of countries is China, the USA, France, United Kingdom, and Japan. The first graph shows the Australian exports to these countries, the variance over the years, and the second graph shows the exports for New Zealand. Finally, the final visualization tool is a pie chart for different trade good IDs, different exporters. So this graph at the top here shows New Zealand's exports, New Zealand's total exports in the year 2019. So for example, if we change the trade good ID to something like 01, we will see instead the proportions of exports of this particular trade good. Finally, let's look at the data analysis. This is the same data analysis that is used in the thesis. Here's some code to graph the correlation between political indicators and economic indicators. We have two arrays. The X array contains the dependent variables, which are the political indicators, and the Y array contains the independent variables, which are the economic indicators. In reality, the two arrays can be swapped. It doesn't make a difference. The two arrays below here, X covar and Y covar, are the control variables. So in this case, a partial correlation is computed with the effects of total Chinese imports removed from both the economic and the political indicators. However, this can be changed. For instance, if we would like to remove the effects of year from the political indicators, and we would like to remove the effects of total Chinese imports from the economic indicators, we can adjust the X covar and Y covar to do so. So we see currently this is the graph, this is the matrix for the correlations between political and economic indicators with the effects of total Chinese imports removed. If we change this so that it becomes a semi-partial correlation matrix, there it is. And if we want to look at simply the correlations with no control variables, we can simply declare empty covar arrays. And we will see that all of the political and economic indicators are very strongly correlated, with the exception of one, when no control variables are used. So again, leaving both the X covar and Y covar empty essentially calculates the correlation between the economic and political indicators. Setting X covar and Y covar to the same variable effectively calculates the partial correlations, and setting them to different variables effectively calculates the semi-partial correlations. The matrices only show a high-level view of the correlations between the political and economic indicators. The tests for the analysis, however, are carried out more rigorously. So some statistics are obtained in the same function above. The first element is the expected correlation between the two indicators, and the second element is the p-value. So the p-value is compared against the p-test value. For instance, if we wanted to be able to reject the null hypothesis with a 99% certainty, we would set a p-test value of 0.01, and if the p-value is smaller than 0.01, as in this case, we can reject the null hypothesis and adopt the main hypothesis. That concludes the video demonstration. I hope you have learned something about how to use the code in this project.